Hey math kids, today we're going to talk about speed, and speed is just the absolute value of velocity. So it's velocity, but we don't really care about the direction where it's going. Now, there's another rule we want to talk about. So if the signs of velocity, so this is the signs, so positive or negative, so sign of velocity and acceleration, if they're the same, then the speed is increasing. So signs are the same, that means increasing. Now if the signs of both of those are different, then our speed is decreasing. Okay, so that's going to be important on this next problem that we do. Now we're given a position function. It looks like this. So it's a particle moving. T is greater than or equal to 0. All that pretty standard stuff. Okay, so it says find an expression for the particle's velocity and acceleration. So to find the velocity, we need to take the derivative, and then to find the acceleration, we'll need to take the derivative again. Okay, so this is 3t squared minus 3. That's going to be measured in centimeters per second. And then we get 6t, which is going to be measured in centimeters per second squared. Okay. Now, they want us to draw sine diagrams, and so when they ask us to do things like that, we need to factor. We can take that even further. We can use difference of squares, which is t plus 1, t minus 1. Okay. So we know we're going to cross at positive 1 and negative 1. So for the sine diagram, those are the values we mark. But at 0, that's when time starts. So we actually don't care about any of that. All right, so I'm going to plug in a 0 right here. I'm going to plug in a 2 right here to see what the signs are for my sine diagram. So this is always positive, so I don't really care about that anymore. But if I plug in a 0 here, I get positive, 0 here negative, positive times negative is negative. Plug in a 2, it's positive, 2, it's also positive, positive times positive is positive. So that's my velocity sine diagram. And over here, there's not much to factor. And so my sine diagram is just going to be at 0. We don't care about anything. And because I'm plugging in a positive value always, anything I choose over here, this is always going to be positive. Okay? Now it says find the initial conditions and hence describe the motion of the particle at this instant. So like on a previous problem we did on a different video, we're just going to find S of 0, V of 0, and A of 0. And so we just literally plug this in. 0 and 0 here goes away. So for S we get 1. Plug in a 0 here, we're left with negative 3. Plug in 0 here, we get 0. Okay, so when we're doing that, so the particle is 1 centimeter to the right. That's what the 1 for our S function tells us. We are traveling in the negative direction. So we're going 3 centimeters per second in the left, traveling in the left direction. And then we are going a constant speed, because we are not accelerating at all. Okay. Now part C says describe the motion of the particle at t equals 2 seconds. So we basically do the same thing we just did, but we're going to plug in a 2. Okay, so if I plug in a 2 right here, 2 cubed is 8. If I plug in a 2 here, I get negative 6, and I have my plus 1. And if we add all those together, we get 3 centimeters. Now if I plug in a 2 here, 2 squared is 4, 4 times 3 is 12. Subtract 3 from that, and so we end up with 9 centimeters per second. And then if I plug in a 2 right here, I get 12 centimeters per second squared. Okay, so if I put that into words, we're going to be 3 centimeters to the right, because it's positive. We'll be traveling in the right. Our velocity is going to the right, and we're traveling at 9 centimeters per second. And our speed is our acceleration, we're speeding up, that's what I'm trying to say, at 12 centimeters per second squared. All right, D, find the position of the particle when it changes direction. So that's where we go back to our velocity. We see that it only changes direction once, and that's at s of 1, okay, or t equals 1. So at t equals 1, we have a direction change. Once again, it's where the sign changes right there, which is t equals 1. Find the position of the particle when it changes direction. And so all we have to do is find s of 1. So plug in a 1. 1 cubed is just 1. Negative 3 times 1 is negative 3. Then we add 1. So we add all those together, we get negative 1. And so what that means is that we're to the left 1 unit. Okay? Now, what I'm going to just erase this right here. And they want us to draw a motion diagram. So when we're doing this, the furthest we go to the left is negative 1. And then when we plugged in 2, we went to 3. So that's the furthest that we know about. So that's how I decide to draw my number line. Now we're going to first look at our initial conditions. And that says we start 1 to the right at t equals 0. Oops. I'll do a different color. So t equals 0. That's where we start. Now, we plugged in 1 second, and that's where the direction change was. We found out that we were 1 to the left. And so the next place we go is right here, and that's at t equals 1 second. And then we just need to connect those because we go that direction. Okay. And then the next thing we know, really the only other point we know, is right here. We're 3 centimeters after 2 seconds. So we're 3 over here, and we go that direction, and that happens at t equals 2 seconds. So draw some arrows in there. We're going this direction, and then we're going this direction. So that's our motion diagram. And we can assume that we're continuing traveling this way. And now the last part, for what time interval is the particle's speed increasing? Okay, so the speed, so it increases when we have same signs between our velocity and our acceleration. And so if we just look at these two sine diagrams, and we were to kind of lay them on top of each other, we see from 0 to 1, they have different signs because this is positive and this is negative. But then after 1, they're both going to be positive forever. And so we can just say for t is greater than 1 or equal to. Okay? So when t is greater than 1, the speed is increasing. If you need additional help, please come to Math Lab. Until then, calculator.